Hello and welcome to Dr. T's Algebra 3 and Trigonometry. In this video I'm going to look at a couple examples from basic trigonometry. In this one we're looking at motion on a circle. So there's an object traveling around this circle. Let's think of it like the unit circle, so we're starting on the x-axis and then moving in a counterclockwise direction. Where 360 degrees, or a full circle, would be 2 pi in radians. And then we've got those milestones here where pi over 2 is 90 degrees, pi is 180 degrees, 3 pi over 2 then is 270 degrees, and 2 pi is 360 degrees, but it's also 0, it's a starting point. And then that tracks around and around, as we could also look at the parts of a right triangle as they make sine and cosine waves, but that's another video entirely. So the question asks, if we have a radius of 12 centimeters and the object moved 1/6 radian in 40 seconds, then what's the linear and angular speeds? The angular speed is the speed that they're moving around the circle, right? It's not the same as moving in a straight line because there's another direction involved, right? And that's going to be given by the theta, or the percent of the circle, or the fraction of the circle that's traveled within that given time. And then the linear speed is going to be that one, just the radius times the angular speed. So looking at our numbers here, then the angular speed is at omega. It's not quite a W. I write it like a W, but it's a little bit wider. It's a lowercase omega is equal to 1/6. That's our movement. That's the theta. And then that's going to be divided by 2/3 minute. I'm just going to keep it in minutes. And then our final answer will be in centimeters per minute, or radians per minute. And so we're going to keep change flip. 1/6 divided by 2/3 is 1/6 times 3/2. And that's going to give us 3 over 12, or 1/4 radian per minute. Okay, then we're just going to plug that right into the other formula here. R is 12 centimeters, and we're multiplying that by 1/4 radian per minute. And we're going to end up with 12 over 4, which is 3 centimeters per minute. And we can look at some online help here where they've got lots of different calculators. Angular velocity calculator, we can do linear, angular. Let's try angular velocity here. I've already got it added in. So 1/6 is 0.1666 on out to infinity, but we just rounded it here. Radians, and then 40 seconds, output in radians per minute. Calculate that. We get 0.25, which is 1/4, so that was correct. And then let's look at linear velocity. 12 is our radius, and then 0.25 radians per minute was the value. Delete one of those dots. Okay, and calculate. And what do we get? 0.0005 meters per second. It won't give us our answer in centimeters per minute, which is what I calculated. So let's convert meters per second into centimeters per minute. So it was 0.0005 meters per second. And then we're going to have 100 centimeters per 1 meter. Don't need to write out meter, just M will do. And so those meters are going to cancel out. And then we still got a seconds on the bottom, so we need 60 seconds over 1 minute. So we're going to take 0.0005 times 100, and then times 60. Times 100 is just going to move our decimal point two spaces, so we got 0.05 times 60. 5 and 6 is 30, or 5 and 6 is 30, yeah. And then we're going to move that decimal place over 1 for this 0 here. And now we can say it's going to move over another to give us 3.0 centimeters per minute. Next example has some pulleys. This is pretty relevant for any kind of machine that uses pulleys anyway. So we got 2 pulleys, one with a radius of 4 inches and one with a radius of 9 inches. They're connected by a belt. The 4-inch pulley rotates at 5 revolutions per minute, and that's RPMs. So we got moving around in speed of 5 RPM. Determine the revolutions per minute of the 9-inch pulley. Well, our 5 RPMs is going to be equal to 2 pi r times 5. And we're just looking at the nature of a circle here. If we were going around one full rotation all the way around here, well, and again, our circumference is equal to 2 pi r. So we're going 2 pi r around the edge, right? So this pulley here is going to travel all the way around, and so the actual distance traveled for that pulley, starting at one point on the circumference, going all the way around one rotation, is 2 pi r in linear distance. And then we're going to multiply it by 5 because 5 RPMs, and that'll give us 40 pi radians per minute. And so again, this is the circumference. That's 2 pi times 4. 2 times 4 times 5 is 40. And so let's look at our circumference of the 9-inch pulley. Circumference is going to be 2 pi r, which is 18 pi. And so if this pulley belt, the belt, is moving 40 pi inches as the small pulley goes around 5 times, then we're just going to divide that. All we have to do is divide 40 pi, that's our total distance, by the number of times it'll go around that bigger wheel. It's going to give us 2 2/9 full rotations around the 9-inch wheel, so RPMs. And we could phrase this in terms of angular velocity or angular speed, just 2 pi times 5 over 1 minute, or 10 pi per minute. And then our linear speed is going to be the radius times that velocity there, which is 4 times 10 pi over 1 minute, or 40 pi per minute. So I just looked at the same thing here a couple different ways. And if that belt is moving that distance, then it's this bigger wheel is going to turn, and however many times it turns to travel that distance along the belt is how many RPMs it takes. Okay, we'll get back to this in another video. Thanks for watching Dr. T's Math.